Hi Roboticist, in today's video you will learn how to stream images from the camera that is spawned in our environment in Gazebo, this one here, the kinetic one. So I'm gonna put the link in the description down below to install, let's say, this kinetic camera in our environment in Gazebo. And in particular, we are going to make edge detection algorithm with the OpenCV libraries in real time in Gazebo, like simulating what a camera is getting as an image. So before to start, make sure to subscribe to the channel, hit the notification bell, and as always, if you want to make a deep dive into your robotic journey and start from the beginning course, check out the beginner course in the description. So let's get started. First of all, in the last video, I'm gonna put always the link in the description down below. We have made an object detection algorithm using OpenCV libraries, and we have used this code here, edgedetection.py. And this file is going to be a Python file, but is checking only the image that is getting the camera. So, for example, if we press play here, now our visa is going to okay, as you can see, is going to appear. Now here, as always, you see what the camera, the 3D camera actually sees. And I just remember you that if we are going to run this code, we are gonna see only one image. Let's say the first frame that the camera is getting. Okay, here we are. So this is the edge detection that the camera sees, and is blocked to that frame. It means that if in a robotic application we move in a real environment our object, and we can simulate it by simply translating in the y direction, for example, here. The camera is not showing the image, the position of the object updated. But why? Because it's only getting the first frame. So how to solve this? So what we could exploit here, so actually let's close the here in the terminal. So again, what is blocking us from getting a stream of image is this value here, CV weight key 0. So why that? Because if you see the structure of this Python code, you are gonna have the class object detection here and the main. So in the main, what we are gonna have is okay, we initialize the node, we are calling an instance of this class, and we are gonna try ROS spin. So meaning that, imagine that you're gonna have an infinite while loop that is keep going. So the ROS spin function is a function that keeps your node alive. So meaning that the main function is do again and again in a while loop. And what is gonna do again and again is the instantiate of this object that is calling the class object detection. And is on in object detection, you're gonna have the constructor here where we are gonna have our subscriber. Here is the object that allows us, I remember you, to convert the image that is getting from the ROS environment into an image that the libraries OpenCV can actually process. And then this is the callback function necessary for the subscriber. And at the end here, we have our algorithm. I'm gonna put the link now. We are gonna show our image, and we have a CV weight key. If you put 0, is meaning that you are gonna freeze the frame as it is, the first frame. So if you put the value 1, is meaning that this frame is updating every second, every 1 second. So let's give it a try. Okay, you can see here that now is displacing in the other way, and the edge detection is actually working, and see that the square is actually updating every seconds. And if we want to test it, we can just move and translate in x in y direction just a little bit, and let's see if the image is updating instantaneously. Here we go. Okay, so you can see that now we are streaming the image from the camera. Okay, so this is the first part of this video. As you can see, it was very easy. What I wanted to point out here is that, you can face here a problem. The problem is that this algorithm, the edge detection, and the fact that we want to inscribe our object that you want to pick into a square, a blue square like this, well, this square is not precise and is depending on the position of the object that is gonna be. Okay, you can see here that in the center we are getting a good inscription of the object, but if we move just a little bit, for example in the positive y direction, if we try to put in the center, let's see the situation, and it's gonna be better. Okay, I think that you got the problem here, and you can imagine that this problem increase if you are you're gonna be in real life, in industrial application, where it's very important that the object is perfectly detected, because you can see that the position, depending on how the algorithm detect the edge, the center can change, can be moving, can change during the time, and this is something that we don't want to do, because if, for example, the object is just slightly on the left, we want that the camera actually get the precise position of the object, because, for example, we want to pick it. And if this square is not inscribing perfectly the object, then we have the center here that might change to the respect to the real position. Okay, I hope that you get the problem, and let's find a way to solve it. Okay, let's close. And actually, what we can do is to create another file, and we can call it stream images, or better, stream camera .py. Okay, we can first of all just copy and paste everything, because it will be similar. Okay, so how to tackle this problem? As we've seen from the image, it seems that the box is not subscribing well. So let's do some troubleshooting here. The box that we have created is created from the contour detected to the object detected here, and this is belonging to contours, and the contours is here. So basically here is the problem. So actually what we can state is that this is not proper. And why that? Because so it seems that if we move the object, these functions find contour is not working properly. Or better, it's not the fact that the function is not working properly, it's the fact that we are using a mask here, or better, we are using an image to find the contours that is retrieving from the image for the conversion, let's say, of the image from BGR to gray. Then we have created an adaptive threshold to gray, and then we have used this as a mask. So the approach, for example, is instead of passing to this function find contours, this mask here, we could pass a mask that is based on the color. So basically what we have did in the color filtering file. Okay, let's do it. So let's put this from one side, and let's modify this function here. Okay, since that we are basing our mask into the color, well, it's not necessary to crop the image for the moment. We are gonna see later on. So we are not converting the image to a gray. Actually, we don't need to display the image, and we are not using the adaptive threshold to creating a mask. Okay. What you can do is to convert the image from color BGR into HSV. Then I don't want to explain again, because I made a specific video for creating a mask using a color filtering and how to get the value of minimum red and maximum red. I'm gonna put the link in the description down below, and we are passing the CV image here, and then we create a mask based on this range. We don't need to use the bitwise end function, and what we can do here is to pass this mask in red and see what's happened here. And the polylines, so here the contours, this new function will detect the contours based on the image that we are gonna pass, and we are not passing a mask generating from the conversion of the threshold in gray, but you are gonna pass an image that has been retrieved from a mask of the color, and let's see if it's gonna work. And then we are gonna draw a polylines directly in the image, in the object that we detect, and we are gonna pass the CV image. Okay. Then we are gonna have a filtering, because we can have multiple objects here. Here should not change nothing. Okay, it should be fine. The only thing, so the text, instead of having it in a green, let's put in blue. So let's put this and 0 here. Okay, let's see what happened by running this code. Okay, I run some tests and I think that I made a mistake. So basically we need an adaptive threshold, of course, because otherwise we cannot compose our mask. But with the difference that instead of passing the image gray, we are gonna pass the image mask R. Yes, and then we are gonna pass here as a contours the mask. Okay, so again, it seems that we cannot pass into fine contours a bold image, and the mask what is gonna do is creating some kind of rectangular based on the mask. So let's try it. In order to see what's happening, I'm gonna remember you what is gonna be, and let's uh, um, let's um, let's show. Okay, now it should work. Let's run it. Okay, now it's gonna be better. So let's move. Okay, now you can see the center here of this box. Let's move it here at the extremity of the table 1 and see if the box is inscribed in the object. Okay, the situation seems to be better. There will be another improvement and that we can make, but we are gonna cover it in the next video, where we are gonna place the camera right on the top. So we will see not this rectangular, but we are gonna see the square of the top part of the object. I wanted you to practice about it and to see if your algorithm works good. You can imagine that tweaking the parameters of your OpenCV libraries is very important. And you can see that we still have some little problem here if we are doing if we are dealing with a simulated environment. And you can imagine that if you're gonna see if you're gonna deploy this system into an industrial machine where you're gonna place this station, this robotic station, in a factory where you are gonna have the light that is changing every time. You're gonna have some people that's passing by. You're gonna have some shadow and so on and so forth. Is very important that your algorithm will be stable regardless the noise. But for doing that, in the next video, I'm gonna show you how to improve it as much as possible. Okay, I hope that you enjoyed this video and this video was useful for you. If you like this video, make sure to subscribe to the channel. Tell me what you think about this series in OpenCV, specifically applied for robotics and in particular with ROS. Have some fun in practice with this algorithm, and as always, keep learning robotics with ROS.